Hi everyone, this is Vijay Lakshmi Sugnali from WinMaths. Here, in this video, we will discuss the exercise problems on relations and functions for second PUC mathematics. Now, let us discuss the first question. What is that? Exercise 1.1. The first question will be determine whether each of the following relations are reflexive, symmetric and transitive. Before going to solve the problems, we will discuss the definition of reflexive relations, symmetric relations and transitive relations. Okay. Now, if a relation, let a relation R in a set A is called a reflexive if A comma A belongs to R. Similar element. Okay, if A comma A belongs to R, for every A is belongs to A. Again, if a relation is symmetric, if A1 comma A2 belongs to R, that implies A2 comma A1 is also belongs to R for every A1 and A2. Again, for the relation transitive, if A1 comma A2 belongs to R, then A2 comma A3 belongs to R. That implies the A1 is comma A3 R belongs to R for every A1, A2, A3 belongs to set A. Then these three conditions are satisfied. We say that it is an equivalence relation. Now, check the reflexive, symmetric and transitive condition for the problem first. Relation R in a set A is equals to 1, 2, 3 up to so on for 13, 14 defined as relation R is equals to x comma y such that 3x minus y is equals to 0. Okay. Both elements of x and y are belongs to 1, 2, 3 in set A. Okay. Now, check the first condition, reflexive. Okay. Before going to check the reflexive condition, we have to write the relation. That is, R is equals to, we have to write the relation in a order pair. Now, consider 3x minus y is equals to 0. Then x is equals to, that is 3x is equals to y. X is equals to y by 3. Okay. Or consider y is equals to 3x because we want the value for y. Here now substitute the value 1. Okay. Now substitute the value for 1. We get y is equals to 3. For x value 1, we get y is equals to 3. Similarly, for x is equals to 2, we get 6. For x is equals to 3, we get 9. For x is equals to 4, we get y is equals to 12. Then x is equals to 5, y is equals to 15. Okay. We already know the condition x and y are belongs in the set 1, 2, 3 up to 14. But here for x is equals to y, we get 15. The 15 is not present in that set of A. Now, we write the relation 1, 3, 2, 6, 3, 9 and 4, 12. These are the order pairs of the relations. For these order pairs, we have to check the reflexive condition, symmetric condition and transitive condition. Now, for reflexive, consider any element of order pair 1, 3. But our reflexive condition 1, 1. But here 1, 1 is not there, 2, 2 not there, 3, 3, 4, 4 not exist in that group. So 1, 1 not belongs to the relation R. Similarly, 2 comma 2 not belongs to R. Not belongs means it is not a reflection. It is not a reflexive. Again, check for the condition symmetric. Now, by the condition of the symmetric, 1 comma 3 is present. Okay, consider order pair 1 comma 3 belongs to the relation R, but 3 comma 1 not belongs to the relation R. 1 comma 3 is belongs to the relation R, but 3 comma 1 is not belongs to R. Hence, it is not a transitive. Sorry, hence it is not symmetric. Again, check for the condition transitivity or transitive. Now, consider 1 comma 3 belongs to relation R and 3 comma 9 belongs to the relation R. That implies 1 comma 9 not belongs to R. Okay, by the condition of transitivity, 1 comma 3 belongs to R. Again, 3 comma 9 is belongs to R, but 1 comma 9 is not belongs to relation R. Hence, it is not transitive. Okay, it is not transitive. Next, second question. Next, we will discuss the second question. Relation R in the set N of natural numbers defined as R is equals to x comma y such that y is equals to x plus 5 and x is less than 4. Here the order pairs. What are the order pairs? X comma y. The condition is x values are natural numbers already given. R is the relation is the set of natural numbers. In that natural number, x must be the values of the x are taken natural numbers less than 4. What are the natural numbers? The number starts with 1. Okay, the number starts with 1 and the numbers are positives. Okay, the values of x will be taken as, check the relation for the values taken relation R. Okay, x values are 1, 2, 3. Now for order pair, put x comma y, that is 1, y value becomes 1 plus 5, 6. Again for x value 2, y value becomes 2 plus 5, 7. For x value 3, 3 plus 5, y becomes 8. Then the relation will be order pairs 1 comma 6, 2 comma 7, 3 comma 8. Okay, now check for reflexive. Okay, check for reflexive. Here order pair 1 comma 1 not belongs to R. Similarly 2 comma 2 not belongs to R and 3 comma 3 not belongs to R. Hence it is not reflexive. Similarly, for check the condition symmetric. Here a relation 1 comma 6 is belongs to R. That implies 6 comma 1 not belongs to R. 1 comma 6 is there in relation R, but 6 comma 1 is not belongs to R. It is not symmetric. It is not symmetric. Again, for the condition transitive. Here, there is no order pairs for transitive relation. Okay, there is no order pairs for, there is no order pairs satisfies the, there is no order pair satisfies the condition of transitivity. Okay, this is the solution for second one. Now question number 3. Relation R in the set A is equals to 1, 2, 3, 4, 5, 6 as relation R is equals to x comma y such that y is divisible by x. It means y is divisible by x. It means y divided by x. It means y divided by x. That is a relation R is equals to x comma y divided by x. Now check for the condition reflexive. Condition reflexive. Here x comma x such that x is divisible by x. X is divisible by x. Okay. Hence it is reflexive. For example, 1 comma 1 belongs to R, then 2 comma 2 belongs to R, up to so on for 6 comma 6 belongs to R. By this condition we say that it is reflexive. Again we check for the condition symmetric. Okay, in that symmetric we have two elements or two values. R is equals to x comma y such that y is divisible by x. Y is divisible by x, which is belongs to R. Again y is divisible by x and y comma x such that x is also divisible by y, that is belongs to R. Here we check this condition for taking an example in the set. Now we check the symmetric condition while taking an example of order pair in the set A such that 2 comma 4 such that 4 is divisible by 2. Okay, that is 2 comma 4, 4 is divisible by 2. Similarly, that implies for 4 comma 2 such that 2 is not divisible by 4. 2 is not divisible by 4. Hence, it is not symmetric. Okay, 4 is divisible by 2. We get 2, but 2 is not divisible by 4 because compared to 2 and 4, 4 is the larger number. Okay, then third condition, transitive. Transitive. Here the relation R, x comma y such that y is divisible by x. Okay, and relation for y comma z such that y is divisible, z is divisible by y. Combining these two relations, combining these two relations, that is r is equals to x comma z, such that y divided by x and z divided by y. It can be written as y divided by x into z divided by y. Y will get cancelled. R is equals to x comma z such that z is divisible by x. Hence, it is transitive. Hence, it is transitive relation. Next, let the question number 4. Okay. Relation R in the set Z of all integers defined as R is equals to x comma y such that x minus y is an integer. Okay. Z here. Z is the set of all integers. It contains negative values, positive values as well as 0. Now, check the condition for reflexive. Okay. Reflexive condition. Here the relation R is equals to x comma y such that x minus y is an integer. Here we consider the value 1. So 1 comma 1, that is for 1 comma 1, 1 minus 1 is an integer. Here 1 minus 1 will be 0. 0 is also an integer. Okay, 0 is also an integer. Hence, therefore 1 comma 1 belongs to R. Similarly, for checking 2 comma 2, 2 minus 2, that answer will be 0. Again for 2 comma 2 belongs to R. For every value of integer, we will get an integer. Then second one condition, that is symmetric. Symmetric. Here symmetric means by the condition R is equals to x comma y such that x minus y is an integer. Then taking minus common from these equation, minus will be taken as a common, that is y minus x is an integer, because we already know that the integers contain minus 2, it has a minus value, 2 it has a plus value, that means minus of y minus x is also an integer. By this definition we have to write y comma x is also an integer. Hence, therefore R is symmetric. Similarly, for checking third condition, reflexive, symmetric and transitive. Transitive, we have to consider 3 integers. Okay, first x comma y is x comma y, x minus y is an integer. And relation R y comma z, it means y minus z is also an integer. Again combine these, again combine these, we will get, combine these, we will get a relation x comma z, that is x minus y plus of y minus z is also an integer, that is plus y minus y will be get cancelled, hence x comma z such that x minus z is an integer. The transitive integer, the transitive condition is also satisfied, therefore it is transitive. Okay, now another exercise problems we will continue in next video. Thank you.